hopefully explain to us what the heck is going on with the physics.
With the physics in this, well, certainly if you guys have, does anybody have any questions about anything that they're immediately wondering about? Just where we just go through this or whatever.
Who's right?
What is physics? That's a good
Jason
question.
wanted me to record this. Is that going to be okay?
Yeah, okay.
All right.
I don't know if it's gonna be that good, but
YouTube.
YouTube.
I have a first question. It's in Morgan Garcia's statement.
Okay.
Line. So it's line 65. So he says that the lieutenant should have used the coefficient of 0.25 instead of 0.10. Is it such a big difference?
Well, that will make a difference in the end result.
No, yeah, I know, but like.
Well, okay, so are you asking like one guy picks the 0.10, the other one picks the
Yeah.
0.25.
Yeah.
How do you know which one to go with?
Yeah, and like.
Well, unfortunately, in this type of situation, there really isn't any way for us to know which one to go with. There is no, like, I don't know what the standard is that, like, what do the police officers use? And obviously, they've adjusted it for what this whole, whole mock trial thing is. So there isn't any way to differentiate. Now, obviously, the officers using whatever experience they have and saying it's 0.1, well, the other person who is being paid to, for the defendant is, of course, deciding that it's 0.25. Why they do that, there's no reason that it says. And there's no physics to say what it is about that other than just the fact that they've picked those based on their experience. So there isn't anything physics-wise that you can answer that with, I guess, is a way to answer that. But, I don't know, just to run through this and talk about it, we're going to talk about a discrepancy we have, a little problem, a little issue. So the whole idea is, and as you guys all know, you've got the car sitting here, you've got the truck coming into the intersection. So the officer involved, what's the officer's name again? Stillday. Stillday figures out, they believe, of course, the car is sitting right behind the stop line. And what he ends up figuring out is that he measures the distance up here to where the accident is, so it's 44 feet. For that distance, he calculated using a standard acceleration. So supposedly,
Hang on a second.
What's that?
Does everybody understand the 44 feet thing?
Yeah, I don't know where
Okay.
everybody's at. I'm assuming.
Where the car started, Johnson's car started to where the accident took place.
Yeah, so it's a distance of 44 feet. So through physics, now they don't actually say what the acceleration of the car is. Supposedly this officer's got a computer program that when he says it's a Dodge Neon, it'll kick back and say the car accelerates at a certain rate, whatever that is. So what he figures out is he says, this person's sitting at the light's red. The light turns green. He processes out that it would take at least 1 second for this person driving the car to even realize that the light has changed. That's reaction time, okay? And then what he figures out is it must take about 3 seconds, they call it 3.02, we'll say seconds, for the car then, for this person to take their foot off the brake and hit the gas and accelerate forward to this point.
That's included in the 1 second.
Yeah, and so this gives you the total of the 4.02 seconds that it took this car to get to that point. And that's at the start of the green light. So the green light goes off and this is what happened. Okay, so that itself is fine. Now there was one question about this was, is the 4.02, does that have the 1 second in it? And that's on, if you look on page 30 or 24, he's talking about, so his second page of his statement, line like 80, 90 or whatever, 89, 90 right there. It says that there's critical future calculation. First, I measure the distance of the car from the stop line to here, which is 44 feet. And based on average human reaction time of 1 second, time necessary for the light to change and for you to realize it, plus the rate of acceleration, determined that it would take this amount of time for the car to go from there to that point. Okay, so this is kind of a key thing, is he believes it took this long from the point that the light turned green. Now, the idea is then, is it works backwards. Well, actually, the next page you flip over, and so you get to the truck. So you've established this time right there. And so when the truck hit here, the truck skid over this way. I think it was 160 feet is how far it skid. And so what he does is he looks at it. They use this device. It's just an I-beam, and basically all it is just this device that has a bottom on it that's made out of tire rubber. And this thing has a certain weight, which I believe was 22.5 pounds.
Yep.
And the idea is that if you pull this thing, however much force it took to pull it, in this case I think it was 16 pounds, it's just a ratio between those two. You take the 16 pounds divided by the 22.5 pounds, And what you find is you get this value right here. Now they call it a,
And again, uno momento. I don't see a whole lot of pens moving.
Did earlier.
Good.
Physics.
they're just waiting for the big surprise. at the
Yeah,
end,
no,
yeah.
we need, if you're doing either the cross or the direct on either of these people, you better have everything on this board down on your paper, because you might have to explain it.
picture.
Yeah. So if you're asked, where did this 0.71 come from? And that was the I-beam test. And it's just a ratio between the force pulling it and the weight of the object, is all that is.
It's called an I-beam, you said?
It's an
Yeah,
I-beam,
it's an I-beam.
yeah.
Yeah, I mean.
It's on page 25, at
Yep, sorry,
top
yep.
paragraph.
So
Now,
right-
they say, because it's asphalt, it could be anywhere from 0.7 to 0.84.
So
That's
it,
six-
the industry standard is 0.7, they say, to 0.84. So he believes that his calculation is viable because it fits within
Falls
this
in-
industry
within the ratio.
standard right here.
Okay.
Okay. Now, and they did say, like the road was maybe a little damp or whatever, so it actually fits that this would be on the slightly lower side. The more wet it is out, the lower this value is going to be. The easier it is to pull that.
Write that
Okay.
down.
All right. Or conversely, the drier the better the road, the higher it is. But
So more what?
so the wetter the road is, and this, what this is, we'll just call it, this is your ability to grip the road. And we do this in physics, this is called the coefficient of friction instead of the drag coefficient, but it's your ability to grip the road. How well can you grip the road? Now, as you know, in the middle of winter, you can't drive around as easily as you can in the summer when there's roads or ice. Well, your coefficient or your drag coefficient in the middle of winter might be 0.2 instead of 0.7 when you're on an icy road. So you've got less grip to the road. So really that's what this is a measure, is how well can you grip the road. Right there. And the normal accepted range is right here, and his best guess is that's what that truck actually had because of the tires on there. Now, one of the things he says, like, well, okay, the truck is not in perfect shape or anything like that. So, or actually, there's a system. So these trucks have what are called air brakes on them. We don't, normal cars don't have air brakes, but the truck has a system that once you push the brake, it takes, according to what this guy's data is, 0.25 seconds just for the brakes to even activate. So it took a chunk of time. So even though you hit the brakes, nothing essentially is happening for 0.25 seconds in the way of your vehicle slowing down. Now, the one thing I'm not 100% sure about, somehow this time of 0.25 seconds does directly correlate in their thing to 25% decrease in what this number is right here. Now, why that is, I mean, this, you can move the decimal over and yeah, you get the 25 right there, but how does this amount of time correlate to 25%? That would mean that 0.5 seconds would correlate to 50%, or 1 second would all of a sudden correlate to 100% loss in the brake. Well, it's just a delay in time, it's not a loss in the brake. But they both go through this calculation, they both use this type of thing right here, but so they both agree to this. So it doesn't really matter what it is, it's the fact that they both agree
They
to
both
it.
agree that's
That's
all
fine.
we
It's
care
about the other part of it.
We won't argue that at all.
Yeah. So they both agree that when you apply the brakes, it decreases the overall efficiency because it takes a time delay out or whatever. So that's fine. But now the next part he says, on top of this,
Line 107.
line 107, on top of that, he also then says, because the truck is in crappy shape, there's some tires that are bad, there's some brake alignment that are bad or whatever, that it's actually, there's another 10% decrease in what the total ability of the truck is to stop. So this is ideal right here, but because of these two things, it's going to decrease its percentage's ability to stop. And so the total decrease is 35%. And so what they do to actually get his 0.46% is they just take 35%, which is 35, times 0.71, and that's where you get the 0.46 from. So this is the number that they're actually using to determine the braking ability of this
They
truck.
take the 0.65 times 0.71, not 0.35.
Or,
They
I'm
take
sorry,
the
yeah,
100 minus
sorry,
0.5.
I did that backwards. So they're taking 65% of this because it lost 35%, so it's left with 60. So 65% of that was this guy right here. Correct.
Okay, that makes sense.
And this is
Okay.
the number
Do
used
both-
by-
This is still the still day. This is the officer.
Do
or
both
whatever.
sides agree on the .46?
Okay, so this
No.
is where part of the problem comes in, is the other guy believes that this number is not 10%, believes that this is 25%.
Wow, so
Okay, so they both agree on this, I'm pretty positive. This one is what they don't agree on, which means that he believes it should decrease by 50%.
Okay.
And hence, the other one, if you take the 50% times this, the other one had, what is that,
0.35.
Yeah, 0.35. And so this is how this guy arrives at a smaller, a less grippiness to the road, we'll say. So this guy has more grippiness to the road, this guy has less grippiness to the road. Yeah. Oh. Okay, so we've got, this is how they figured that out. Well, going back to this guy, remember that this truck took 660 feet to stop him. Okay, well, he believes that if the truck took this far to stop, and this is its grippiness to the road, this is how well it can stick to the road, then putting those together, and they don't actually go through that calculation, but he believes that the truck then must have been traveling 47 miles per hour based on that. When it got to this accident point,
Still day. Still day.
but Still Day says this is all Still Day, yep, except for this part down here, but he believes that if the truck took this far to stop, 160 feet, and this was essentially its ability, its drag coefficient they call it, to stop, you don't divide them out or anything like that, but you work these numbers together and you find that you get 47 miles per hour. They don't do the physics of that. I don't think you're intended to do the physics.
No, we're not.
You don't actually have enough information to do the physics on that anyway.
But-
Acceleration.
Okay, but the neon is now perpendicular to the truck
Correct.
as the truck is sliding into the Super America corner there.
Yeah, I forget which one it slid into, but
Yeah.
wherever
Yeah,
it
it's that
slid
one.
into.
Doesn't that?
Affected?
Yeah.
I know, that's what I thought too. So, that
You
was a
got
question
four
I had.
tires going in the wrong direction.
Yeah, shouldn't that slow it down and stop it too?
Dramatically, you would
I
think.
think it totally does. And so I think that's a good point to bring up. That was a whole nother thing I wanted to talk about is, this is the brake skid mark distance, that's 160. And based on that, now I don't know if this number, because they don't really go into any type of calculation, is this number dependent on the fact that they're dragging this car along? I don't know that. It doesn't give any, there's not enough information to
Yeah,
actually give
and,
the physics
and
on
please, folks, don't plan on bringing that up in court. That the numbers are all wrong because the trucker is pushing the Dodge Neon. We can't use that. It's an extrapolation that definitely affects the case. And if somebody tries to use that, you will object profusely and vehemently.
So a good way to say this is the way they calculated this, it appears. It's like the car isn't even there and the truck just slammed on its brakes, slid for 160 feet, and because of that and knowing how it can stop, it must have been going this fast. It's kind of like without the car in there,
Right,
basically.
Took the Neon out of the
And I don't know if they're
equation.
considering the truck is so heavy compared to the Neon that it makes such a minimal difference for it to stop. I don't know.
Overloaded by like 6.
When it was
Yeah.
overloaded, which is
But
another
even
problem.
so, you got those
It's
four
gotta-
tires
it's
that
gotta
are
affect it.
perpendicular the
Yeah.
direction.
I
That's
thought
gotta
about
be
that,
something.
but there isn't anything in there that indicates that
Okay.
in any way.
All right, good to know.
But so this guy comes up with this 47 miles per hour. That's how fast he must have been going at this point to stop here over that drag. All right, so that itself is fine. Now, there is one big, huge problem with this. Is what we figured out here was this time. This was the time once the green light activated, the 4 seconds. Okay, well then what they do is they do a little calculation. They take 47 miles per hour. Now, here's the problem. This is, what was that, 160, or was it 68.9?
Yeah,
This is
68.93.
equivalent to 68.9 feet per second. It's a little goofy because we're in miles and we're in feet, and so that's creating some problems there too. But this is how fast he believed the truck was actually going, 68.9 feet per second, which is the same as the 47 miles per hour. Well, if you use this time, or this velocity, and you use this time, you arrive at a distance that this truck must have been back from the accident was 277 feet. Okay, but if you look at line 115 on page 25, It says, assuming a constant speed of 47 miles per hour for the truck approaching the intersection and 4 seconds of green, because remember we decided there's 4 seconds of green for this, and 1 second of all red, the truck would have gone 277 feet from the intersection when the light was eastbound on the red direction going this way. Well, the problem is, if you take the 4 seconds plus the 1 second, you don't get 277, you get 346, I think.
Yeah, 346.
346 is the total distance. Okay, now that's something I'll say we figured out and not go with, this is what the paperwork says here, it's 277. So this creates a little bit of a problem because I think they've actually messed up on what they did here in their calculation. That's question number one. What do you think about that? Is that how you would read it? What do you guys think the amount of time should be? Is it 5 seconds or is it 4 seconds? Should this 1 second of time be factored in there? Now, there's a whole nother question is, does this guy have reaction time right here? Shouldn't he once the red light went on, and so the idea is where that extra second comes from is this right here. So there was 4 seconds of green, that's this guy, plus this 1 second of red, which should be a total of 5 seconds of time.
Plus the potential 1 extra second of reaction.
Well, now they never talk about the truck driver's reaction time. Shouldn't the truck driver have reacted? Now, maybe what they're doing is they're saying that they factored in the reaction time of the truck driver, so this is the right distance because that extra second of red was equivalent to his second of reaction time, and they just canceled each other out. Oh, yeah. Oh, go ahead, George.
Doesn't that one of the testimonies? I think it says that he pushed the brakes when he saw the car coming into the car proceeding to like enter the intersection, not when he saw the light going from yellow to red.
Yes.
Yeah, he never put on his brakes when he saw the light change.
Well, I think that was one of the questions, whether it was screeching of brakes or not, or whatever, something like that.
I don't know. Eyewitnesses say different things.
Different things for it, yeah. But even whether he did or not, depending on where he put this on, this how did I actually approach this? Is the do we compensate for the fact that it, and again, lines 115 to 117, 18 or whatever, doesn't say the truck driver had a second of reaction time. If you're assuming the 1 second of red was his reaction time, then he would have been 277 feet away, would have been the time needed to actually stop for that. Oh, yes.
Okay, so I don't see how you can relate the 68.9 feet per second to Katherine Johnson's time to the point of impact. Like, that's her time to get to the point of impact. How does that relate to Ferris's speed?
Oh, okay. So this right here is actually not determined with this at all.
Yeah.
Right here. So you're saying, how do you get this?
Yeah, how do you get to the
how do I get
distance
this?
from Johnson's time to the point of impact?
Okay, so just to go back a step, is this distance of skid plus this ability to stop is what gave us this. It had nothing to do with this car yet.
Mm-hmm.
But now because he was going that fast, or we believe him to be going that fast, which again is this 68.9, and if we use this time right here, we believe that she initiated this at the instant the light turned green. Okay, and so that's why there was 4 seconds for her to see what was going on and then to actually accelerate forward. That's where this 4 seconds comes from. Now, how does that relate to the truck? We're just using this because that gives us a point of reference for when this light turned on here. So we know that the light had to have been green for 4 seconds, plus you add in an extra second for the red light, and that tells you, using this speed right here, how far back that person must have been.
Okay.
But the problem is, according to what this says here, they used just the 4 seconds, even though they said there should be an extra second for the red. So you could technically take off that second for the red if you factor in the fact that the truck actually had reaction time. Now, here's where the real problem comes in, too. Is Garcia says that later on, it's kind of skipping ahead. But, well, Garcia's point is, he said that if the truck is going 47 miles per hour that it would take 305 feet to stop. Okay, that's what Garcia says. Now, Garcia doesn't believe it's going 47 miles per hour, but if it was going 47 miles per hour, it would take 305 feet for stop. Well, this guy said that Stillday said, well, the truck must have been 277 feet away. So it was somewhat justified for why this guy didn't stop, because his truck would have taken a distance greater than 277 to stop. It would have taken 305. Problem is, if you add in that extra second of time for the red light, which is what it says here, it should have been a distance of 346 feet that the truck was back. And what this guy said about it, what Garcia said, it should have actually been within the distance to then stop.
Yep.
And so it creates a little, I don't know if it's just literally what mock trial wrote up here, if they did it inconsistently, if there's something that we're missing about it. Now, if we do assume that the truck used a 1 second reaction time, which would cancel out the 1 second of the red light, then it would be this far back. But it doesn't specifically say there's any reaction time for
Yep.
that. Okay, so I
But
mean,
that does fit with Ferris's witness statement, that he looks up, the light just turned red.
Didn't he look up and it turned? I thought what it said is it was green. He looked at his phone, and then he looked up and it was yellow
Yeah,
right
that's
away.
correct.
Yeah.
Okay.
And so then he thought he could beat the light. But then,
gunned it.
yeah, he gunned it. Well, supposedly he gunned it or whatever, not. And then yeah, that was the thing. So that's where there's a little discrepancy there. But if you go to, I should have done that in a different color there too. But if you go to the other person, Garcia.
Get over to Garcia,
So
32.
Garcia, and we kind of touched on this already. So Garcia differs from Stillday in this calculation right here. Garcia believes the truck was worse off than what the Stillday said, and so it lost 50% of its braking ability. He agrees with this, although he questions it at first and says, well, there's a better method nowadays where cops have a device on their car, and supposedly the cops will just drive down the road, slam on the brake, and they'll skid along, which I find really interesting because cop cars have analog brakes in them. So they don't lock up like a tractor trailer would, especially an old Kenworth tractor trailer.
Yeah.
So, which I thought that was interesting. I don't know how that
That
compensates.
sucker would be on its side,
Yeah.
barreling through the Super America.
Yeah, exactly. So, so he does concede this because he was not able to make the distance measurement. So he concedes this, Bun, but he believes the truck is worse off, hence it should have a lower percentage, hence its stopping ability is this 0.35. And because it has this stopping ability of 0.35 over this distance, he believes that it should have been going 35 miles per hour instead of 47. So it's still the same distance that it skidded to a stop, ignoring the car that it's dragging along, but it's still the same distance, but it has less ability to stop, so it had to have been going slower to stop over that same distance. Does that make sense?
Yeah.
That's okay. So that's why he says, well, okay, the truck must have been going 35 at this point. Now, if you use his calculation of the 35 miles per hour, where's that one is?
51.3.
So on, line 76 and 77 is where he says this. And then, and he also questioned this value right here. We should go back to that one. So the problem is here, remember, this is a second to react to the light. This is 3 seconds to accelerate to the center. So a total of 4 seconds. He says, well, this person is younger person. They could have done a jackrabbit start that he calls this. As you're standing at the red light, as soon as you see the other traffic turn red, some people will just want to gun it right there, knowing their light is going to turn green. The Garcia is arguing that's what this person could have done in this case. And the reason that's important is that gives it less time to take to get here. And I believe they said the time was 1.5 seconds to actually get there is what Garcia believes, instead of this 4 seconds. Now again, why is that important? Well, if it was less time for this car to get here from the point the light turned green, that means that this guy would have been closer to the intersection when that happened. And so, and I think he figures out, 128 feet?
Yeah.
Okay, so now, So here's the thing. This is what's goofy is they do factor it in Garcia's time, where they didn't factor it in over here. So he believes this time to be 1.5 seconds of total green light plus 1 second of red light equates to 2.5 seconds of total time of how much green there was and how much red. If you use his 2.5 seconds at 35 miles per hour, you get 128 feet of actual distance. Okay, so in this calculation, they are factoring in that red. In the previous calculation, they're not factoring, they're stating that they're factoring it in, but they're not actually factoring it
Well,
in.
Garcia's actually, they never say they add the 1 second of red.
Yeah, that's the funny part. They
Yeah.
don't say they add the 1 second of red, but if you use just 1.5 seconds
And then you add this
and
second.
35, you don't get the 128 feet.
Yeah,
that
you
he
get
says.
77.
Yeah, you get 77, but so you have to add it in there. So in one place they say they add it in, but apparently don't use it, and in this place they don't mention adding it in, but they apparently do add it in.
Frank does.
So, which
We gotta
as a
see.
physics person, it's killing me. But oh yes,
This is really weird, but as just a driver, would you know like the difference between 15 miles?
the difference.
Would you feel like the difference?
Yeah.
You mean how fast you're going?
Yeah.
Yeah, I would say you probably would. You'd have an idea. And he did say in his statement, he's like, I always drive really cautiously because he had all these tickets, I think, when I read that.
35, yeah, 15 under the speed limit.
And then that other person
Yeah,
said
well,
that
that's
he was
just
going
it.
55.
Yeah, but theoretically, he knows it's a dangerous intersection.
But
Yeah, but
Yeah.
his he knows he was going
Yeah.
close
Yeah.
to
But
guns.
I'm happy
He goes
because
to
he
the
says
alcohol
he,
has-
because he said he thinks he was doing 15 miles per hour. And this is
But he also said he gunned it
Yeah.
to try to beat the light.
35 isn't gunning it. I mean, it depends how much
Oh,
time
he
you have to
would,
speed up the
and-
trailer.
and-
Because it's
Yeah.
overloaded. It's a huge
But
truck.
if you went
Yeah.
closer to Stilldays answer, would it be 47 miles per hour?
Well, so the speed limit on the road was 50, if I remember right. And so, and I think what I remember from reading the truck driver's thing was he felt like he had all these tickets. He didn't want to get another ticket, especially while he's driving truck. So he said he thought he was going slower than the speed limit for sure.
5 is a lot.
Well, which 15 miles per hour would be slower. If you were driving, you would notice that as being a slower time. Now, I don't know, it said it was dark or whatever too, but he would notice that he's going that much slower. Now, of course, I don't know, I guess if you're looking at it from an actual court case, is he gonna admit that he was going 50 miles per hour, 55? No, he probably isn't. But he wants to go, but that's just his testimony anyways. I guess that'd be just hearsay of like, well, yeah, I was going that fast. Well, okay, of course you're gonna say that because it's better off for you to do that. But that doesn't necessarily prove it, I guess. I don't know if you're, so are you wondering it from the perspective of he should have an idea about how, or you're talking about somebody else watching the truck? Or are you talking about the truck
I was just
driver?
wondering that, would it be closer to more of Stilldays answer because it would be closer to his answer, or her answer?
I'm not sure if I understand. Let's say that again. I'm not sure if I get the.
Ferris seems to imply he was going a little under 50.
Correct,
Which
yeah,
goes.
which would be close to Stilldays' answer. That is
You
true.
should know, but he's stupid, so he did it.
Excuse me? I think he's a wonderful person.
There you go. That is. There's
Yeah.
no chance she's a truck driver. right?
Yeah,
Yeah.
since
Okay.
she's the defendant.
Our defendant. There you go.
Our
Yeah.
defense
This is gonna be a weird question, but is there any place that, or any information that says about the maximum speed on that road?
Well, the maximum speed was 50 miles per hour. That's what the
Oh.
speed limit was posted at. Yeah.
So he was not speeding.
So at no point does any of this calculation indicate he was speeding to even begin with. I would say that's true. That I
So
don't
that
think
might
is
not
really
be
up
gross
in the
negligence.
question.
He wasn't
The
going too
question
fast.
is, it's not even that he's guilty of actually this accident happening so much as how guilty he is. Is he gonna get the full, what is it, the gross negligent
Yeah.
or
Or
whatever
vehicular
that, that's
homicide.
really what you're trying to figure out, isn't it?
Criminal vehicular.
Homicide,
Yeah.
or which is the worst one out of the other ones, I think.
Reckless driving.
Reckless driving, so.
CVH, they call it in the legal
Yeah,
world.
yeah, and so, he was really, I mean, his truck was in bad shape. He even admitted he never looked at the truck beforehand, if I remember right, too, because he just got in there and the next truck driver goes or whatever. He was overloaded, which is his responsibility as well, too, and all that, and
I was having a short time.
there you go. He's doing a good job of that.
Mm-hmm.
Just getting into character. So, Well, anyways, so first of all, I guess what questions about this? Is there anything else you're wondering about that?
Does Garcia take in effect like the road?
I don't believe, according to what Garcia did, he did comment on the fact that it had just rained a little bit or whatever, that the road was still a little moist and all that. Technically though, in my opinion, I think that falls out because he accepted the .71 that the cop had. He used that in his own calculation, and this is what would determine that right there. So technically, if it was wet out again, this number could be less, but apparently the cop measured it, and that's what he got, and that was considered a valid, even though it's the older way that they do it, it's not the new way. Which again, I don't like
That was
that. I'm
a
curious
couple
about the
hours
I'm
after
actually
crash,
curious to
so
ask
we don't
Thor
know.
even about that if they have that in the car, because if cars have analog brakes, how does that mimic semi-truck that doesn't have that and stuff too? The other one does because it drags it along. And just one little difference of this, if you have analog brakes, the whole point is you don't skid. Your wheels like try to lock up and then they don't lock up because you have better grip when your wheels aren't skidding across the ground. That has to do with what's called kinetic and
Don't,
static
do you,
friction. But
you don't even drive a squad car, though, do you?
Do we know the distance between
drive
the
it? Still-
impact
yeah,
point
still doesn't
and
drive
like
squad
where
car,
the
does it?
intersection
I
like,
don't know.
starts?
So how do we
Say
know
that
if they
my
have
witness
ABS?
did.
Impact,
Why
to
wouldn't
this
you?
distance
Yeah.
right here. I don't
I didn't
believe
know-
that was
I know
given
it's
as
a
a
lieutenant.
I know Schwab doesn't
I don't
drive
think
a
they
squad
ever
car.
measured what that was. At least it
For
wasn't
his
given as
patrol
a
duties.
distance
Yeah.
on
That seems
it.
like something that would be pretty pertinent
Alright.
to measure.
Well, not necessarily. I don't think it,
It never said
matters
anything about
really
that, but it
because
said
Because that could make
whatever this
sense for
distance
not
is
having
right here,
ABS.
the point is
Either
he
way,
was
they both
still
agree
a
on
certain
that, so
distance
Yeah.
from the accident point, whatever that distance was. Now, depending on what one of these you go with, he was either 277 or what I think is the correct calculation, 346, or he was the 128 from it at that point. And notice what Garcia's saying is well, gosh, he was only 128 feet away from it at the point where he had to make a decision, and his truck, well, you know, they never said how much distance the truck would take to stop in that 35, did they?
Could we figure
They-
that out?
No, we can't.
I don't think you can figure it out.
Because we don't
no.
know the acceleration of the
We don't know. We don't know enough information to actually
And you
determine
couldn't
that.
use it
Yeah,
anyway.
it's facts.
Yeah, because you wouldn't. Yeah.
Yeah. So I guess that was an interesting thing too, is how much it would take to stop, because wouldn't that play? Because that number would have to be, according to him, to be a problem, would have to be greater than what this is, anyways. Because he's saying that the truck could not have stopped fully in that amount of distance. And the truck would have probably then ended up stopping in the intersection anyways, for that to actually happen. So the truck wasn't able to stop. Where the other guy is saying, yep, the truck could have stopped in that distance. This is of course what's bugging me, is that extra second of time.
Yeah.
And
Speaking about
that
that
is-
extra
yes.
second of time, what do you do if you get crossed on that? Like you didn't
We're
factor in.
hoping to get clarifications.
Okay, okay.
But the clarifications aren't gonna come out until after the middle of December,
So have fun with it at the scrimmage.
And at conference as well.
Yes.
And probably at Hamlin as well.
So can you guys, I guess,
This
in
is
what
gonna be like-
in what you do, can you have some sort of, I'll call it physics ready to go? That is, well, if he was really traveling this fast and it was 4 seconds plus 1 second, wouldn't it be 346? I mean, can you do something like that, or is that not
Again, we might need clarification on that.
whether you can even do that?
Yeah,
Yeah.
well,
It's just
you
not
can't
an-
necessarily,
Yeah.
you know, take a drawing board and do
that.
the calculations. You can't do that.
Yeah.
But maybe there's something we can do with the diagram of the intersection.
That's what I said. If we
Well, yeah,
blew
that's
it
what
up
you're-
and we
But there's a
laminated
problem with that because the car's backwards on the diagram at the
it.
moment.
We'll get that fixed.
Are you
Yeah, but
serious?
again, not until
Yeah.
after Christmas.
I'm just kind of somewhat desperate to know if they screwed up or if we're just it's the physics in me wanting to know what the correct answer is.
We'll let you know, Radetzky.
Thank you. That's what I want to know. So-
Well, this is based on a real case.
Yeah, it's based on a real case, but I would assume they've changed the numbers, or maybe not. They
No
didn't, maybe
idea.
not necessarily. So, well, I guess you guys have questions about this. Anything else that you're wondering
says
about
it
on it?
again.
I don't know what else you want to talk about with it.
You've been
that-
phenomenal.
See, thank you.